Good morning all. Here we have the output section of a Homatic output card model 2-083-01-5408, and their complaint was that some of the outputs were stuck on, they were not turning off. So the first thing I like to do is check these P-channel enhancement mode MOSFETs. Their part number IRF 9520. And I do that with my meter set to diode test mode. At the end of the video, I'll show you my drawings of this circuit right here. Now, I like to see if these MOSFETs are shorted, so I'll go from drain to source, and the polarity doesn't matter, but I like to put the red lead for a P channel on the drain and the black lead on the source to see if we get a good diode drop. And there on the first one, let's go back. From drain to source we have 0.582 volt diode drop. Here's the second one, 0.578. Third one, 0.578. Here's 0.581 volt diode drop from drain to source. 0.594 volt diode drop. 0.588 volt diode drop. 0.577 volt diode drop from drain to source on that one. Here's the eighth MOSFET, 0.578 volt diode drop. We're halfway through. It doesn't take long. There's 0.592 volt diode drop. 0.584 volt diode drop. So far so good. No shorts that would cause an output to stay on. 0.593 volt diode drop. 0.580, 0.579 volt diode drop on that one. Here's the last row, 0.583 volt diode drop. 0.593 volt diode drop. 0.580 volt diode drop. And here's the last P-channel enhancement mode MOSFET, 0.589 volt diode drop. No short circuits. No short circuits. So I'm going to power up the 24 volt side that drives the output load through the turned on MOSFETs. And let me move my meter out of the way. Here's a row of optocouplers that drive into the gates of these MOSFETs, and on the input side, the LED side of the MOSFET, is the logic. So I'm going to apply 5 volts to this circuit over here. Now I don't have the backplane that this card plugs into, and I don't have the power supply that this card plugs into. So what I'm going to have to do is take 2 external power supplies, one set to 5 volts for the logic side, and one set to 24 volts for the output side. On the front, let me lift this up and see if I can get it in the camera. On the front are a row of 16 green LEDs. And when that MOSFET that's driving the output load is turned on, these LEDs will be turned on. So we'll be able to see which outputs are stuck on when we turn on this card with those external power supplies. I'm going to show you how, and this is a pretty neat little trick, how do you know where to put the 5 volts and ground on the logic side? Well, you find an IC and you pull up its data sheet and you find its VCC and ground, or VDD and VEE and ground. So set your meter. Let me put my meter back here. I like to set it to beat mode. And I know that right here is a 4081. It's MC14081, and I know that's a CMOS IC. I know that this pin right here, pin 14, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I know that pin 14 on a 4081 is the positive, the VCC. So I'll go down and find which pins on this Euro connector have continuity from here to there. Now look at that, the very first pin, that makes sense. The very first pin on this connector is VCC. So take your red marker to indicate positive and mark that. Now I know that pin 7 on that 4081 is ground. That right there is the VCC pin. Let's go back and double check. Yes, we marked it with the red Sharpie. And pin 2 here, oh look at that. That is ground. So take a black Sharpie and mark that. Because you might be hooking up and disconnecting and hooking up and disconnecting, and if you mark them, you will know visually where to put your positive voltage and your ground voltage. Okay. On the 24 volt side, I've got it mapped out already, but on the 24 volt side, and I'll show you my drawings at the end of the video, I'm going to put positive 24 here on the anode of this diode right here, and I'm going to put the ground of the 24 volts DC on the ground side of this electrolytic capacitor, and that will power up the output side. Let me get our connections hooked up, and I'll be back in a little bit. There's 24 volts DC on this side. Don't get them mixed up. You get your 5 volts, you get 24 volts tacked onto that 5 volt side, and you'll be doing a lot more work than just trying to troubleshoot an output. You'll be replacing all of those 5 volt ICs. Okay, there's a 5 volts on this side, 24 volts on this side. I like to use different wire colors also, so I don't get those mixed up. Okay, this is the 24 volts. I'm going to put that on the anode of that diode, We're going to tack the 24 volt DC ground to the ground side of that electrolytic capacitor. Now here's the 5 volts. Let me double check. Yep, 24 and 5. Okay. Ground of the 5 volts goes to pin 2 here, or the second pin over. That might be pin 31, but the second pin from the top side of that board right there. And then 5 volts goes to this pin. Now we're going to apply our voltage. Look at this, we do have 4 LEDs turned on right now. They are turned on right now. I don't know if you can see them from this side of the board. Let's run around to the front side of the board and you can see which ones are turned on. So it's output 1. Output 9 is flickering on and off. And output C and D are the ones that are acting up. Those are the ones that are stuck on. Output 9 is intermittently on and off. Now what we'll do, we set our meter to volt mode, and we're going to go through and find out which MOSFETs are turned on. We'll start up here. Okay, that one's off. We have 21. Let me turn the light on so y'all can see. Let's go back here. That one is off. From drain to source, we have, let me get my meter turned around so we don't see that negative sign. We have 21.85 volts DC. Next one, that was Q31. Here's Q21. That one's off. We have 22.03 volts across drain to source. And this one, look here, this one is on. This is Q11, Q11. It's turned on. We have 5 millivolts across drain to source. That MOSFET's turned on. Here's Q01. That one's off. 21.60 volts across drain to source. Here's Q71. That one's off. 22.04 volts DC across drain to source. Here's Q61. That's off. 21.81 volts. Q51. That one's off. 21.86 volts from drain to source across the drain to source. Here's Q41. That one's off. And we have 21.92 volts DC across drain to source. Another one is off. QB1, 21.96 volts. QA1, 22.05 volts across drain to source. That one's off. And here's one that's on. Oh, that must be, look, I see LED number 9 flickering. Okay, that one we'll have to note that's Q91. That's the one that's intermittently on and off. Right now it's off. 22 point, look, it's changing. All right, now it's on. 5 millivolts from drain to source, and you saw that at one point it was off. Here's Q8, our Q, let me get off here. There, that's Q81. That one's off at 21.93 volts. Let's go here. This is QC1 and QD1. Those LEDs are on. Alright. That one is turned on. We have 5, 6. It's alternating, but about 6 millivolts from drain to source. That one's turned on. Here's QD1. This is another LED that's on. And we have about 6 millivolts across drain to source. And here's QE1. That one's off. We have 22.14 volts across drain to source. Now let's go look at the optocoupler circuits right here, and we'll find out which ones are turned on, driving into the gate of those P-channel enhancement mode MOSFETs. And we'll look at the input side, and if the input side is turned off and the output side is turned on, that means we're going to have to change those optocouplers. Okay, give me a little bit to move the camera back and get the meter situated so we can look at those voltages. Now we're going to look at the LED input side of the optocouplers and the NPN transistor output side of the optocouplers. Now the nice thing about this board is you can see we have U01, U11, U21, U31, U41, all the way up to UF1. They correspond, the labeling on the board corresponds to the MOSFET that it turns on. So, for instance, U01 optocoupler turns on Q01 MOSFET. Over here, UF1 optocoupler turns on QF1 MOSFET. So it's real easy to tell which ones are turning on what MOSFET. Let's go to the input side of the optocouplers. We'll do all those and we'll see if any of them are turned on. There's U01 is off on the input side. U11 is off. We have 0 volts across that LED. U21 is off on the input side. U31 is off. This LED on U41 optocoupler is off. I'm going to get all tangled up here. And U51's input to the optocoupler, 0 volts. U61, 0 volts. I have to switch sides here. Let me get in the way. U71 is off. U81 off. U91's LED is not turned on to that optocoupler. UA1 the same. Input LED is off. We have no voltage across it. UB1 is off. UC1, the input LED is off. UD1, the input LED has 0 volts across it. That's off. Here's UE1, input LED is off. And the last one, input LED to UF1 optocoupler is off. Now let's go and look at the output side. Here is one that is off. When they are off, they should have about 23.4 volts. Slipped off, 23.4 volts across it. Here we have 23.37. On the output side of U01, that is off. Now, here's U11. We saw that that MOSFET was turned on. Let's see what the voltage looks like. That's not completely turned off. That's why that MOSFET is turning on. We have 16.9 volts thereabouts. It's varying, but it's not fully turned off. Here's U21, the output side of the optocoupler, NPN transistor. We have 23.36 volts, that's off. Here's U31, that's off at 23.37 volts from collector to emitter of that optocoupler's NPN transistor. Here's U41, and that one's off, 23.36 collector to emitter on the output side of that MOSFET. Here's U41, that's off from collector to emitter of that output transistor inside that optocoupler. We have 23.36 volts. And this one, U51, the output transistor's turned off, collector to emitter, we have 23.35 volts. Here's U61, that one's off, collector to emitter, we have 23.36 volts. Alright, I'm going to have to come around to the other side before I get in the way of that meter. Here's U71, collector to emitter on the output side of the optocoupler. We have 23.36 volts DC. U81, that's off. Collector to emitter of the optocoupler's NPN transistor. We have 23.35 volts. Here's U9. This was the intermittent one. And right now it's on. And look, we don't have 23.4. That output is semi-turned on. Not fully into saturation, but it is. Now the LED just went off. The LED is off now. But you saw when it was on, we did not have a full 23.4 volts. Here's UA1. That one's turned off. We have 23.36 volts across collector to emitter of the optocoupler's output transistor. Here's UB1. That's off, 23.37 volts DC. UC1, and look, it's not fully turned off either. About 15 volts from collector to emitter. UD1, and again, that one's not fully turned off either. About 7 volts from collector to emitter. Here's UE1, that one's turned off. We have 23.37 volts from collector to emitter. And this one has turned on here recently. This is UF1. Nope, now it turned off. I don't like that one. I'm going to change that one too. So we have 0 volts on the input side of the optocouplers, and some of the optocouplers have their outputs turned on. Not fully, but not completely turned off. So we're going to change the optocouplers that we saw were partially turned on. When they were partially turned on and not fully turned off, that was enough to turn on these MOSFETs down here and falsely turn these outputs on. So we have 5 we have to change. U11, U91, UC1, UD1, and UF1. That's 5 optocouplers, and I don't have any. I'm going to have to order them. When we get the new optocouplers in, we'll get them changed out, and we'll perform the test again. And I'll show you how to fully turn on and off the outputs from these inputs on this connector right here. All right, all. Wasn't that fascinating? That is fascinating. I like these boards because when you power them up, they tell you which ones are bad. But I always like to check for short circuits first, and that way we don't burn nothing up on the board, open up traces and whatnot. So check for shorts first, and then do the dynamic test that we just did. There we go. That was a lot of fun. Thank you all for stopping by and seeing what we're working on next. Hope you're having a good day. We're doing all right here. Not too bad. We had a big thunderstorm last night. Knocked the power out. I hope I got internet at the house when I get home. Otherwise, I won't be putting up no videos for quite a while. We'll see. We'll see. That was a bad storm. Lightning must have hit us about half a mile away. And it sounded like a Mark 82 going off. Somebody dropped a 2,000 pounder way over there. Okay. All right. Okay. Y'all have a good day, and we'll see you next time.
got 8 now. Two vehicles involved. One patient will be transported. You arrive, pull onto 3rd Street and park behind Battalion 1, please. that back for. Greenway, Shirley.
Here's one output channel of the Homatic output card. The input to this inverter is on C26, and that goes to U15 pin 5, which is 74HC4049. The output of this hex inverter turns on the LED of the optocoupler CMY17-1. We replace this to repair the board. When the output pin 4 goes low, because pin 5 has been pulled up to 5 volts, current flows from 5 volts DC through the current limiting resistor of 820 ohms, through the anode cathode of the input LED to ground inside U15. Photons then are emitted from the LED and they drive into the base of the phototransistor. That drives this transistor inside the optocoupler into saturation, pulling the gate of this P-channel enhancement mode MOSFET to ground through this 10K ohm resistor. That turns on this P-channel MOSFET, and 24 volts DC up here on these pins goes through the source to drain, turns on this green LED on the front panel, and also drives the load. Now in our test we're going to perform, we're going to pull this pin high, and at the output here, in this case on this output channel, pin D8, we're going to have a relay coil, and that coil is going to be connected to ground here on Z30 and Z32. The 24 volts is applied to these pins up here, Z2 through Z28. In our test setup, we have 24 volts applied to the anode of this 1N4007 and to the ground of C1, a 10 microfarad 63 volt electrolytic capacitor. When this MOSFET is turned on, that relay coil will energize. And in our test setup, you'll see in a little bit, the contacts of the relay coil turn on a 100 volt light bulb. I'll put this drawing up at the end of the video so you can take a screenshot of it. Here's our ground on 32Z, and right now we're connected to D2 output. The coil of the relay is connected to these 2 points right here. This is my 5 volt pull-up, and to turn on the D2 output on this connector, I have to pull pin A25 high on this connector right here, and I've got them marked. There's with some pencil down here. The A row is on the bottom, and the C row is on the top. So here's 25. The relay has energized, its contacts have closed, and it's turned on that light bulb connected to 120 volts AC, single phase. Isn't that amazing? That is cool. Okay, let's move to D4. This is pin D4 right here. Now we turn on C25. And C is on the top row. Get down here so I can see. That output's working. Now we'll move to D6 pin. And we want to pull pin A26 high. Nice. So far so good. We'll move to D8. And we want to pull pin C26 high. Nice. Now where do we go? We go to D10. output pin D10, and we want to pull pin A27 high. I don't know if you can see it for the light bulb, but this LED is turned on and off when we pull that input to that hex inverter high. Okay, D12. To turn on output D12, we pull C27 up to 5 volts. C27, C27, there we go. That output's working. Move our relay coil to D14, pin D14, and we want to pull pin A28 up to 5 volts. Seven, 28. There we are. That output's working. Now we're going to move to pin D16, and we want to pull pin C28 up to 5 volts. 5, 6, 7, 28. There we go. There's 8 outputs working. We have 8 more to go. Let's see, where are we? 16. Here's output D18. Whoops. Hang on. And we want to pull A29 up to 5 volts. We're using the same 5 volts that's powering up the logic. A29, where are you? Here's 25, 26, 27, 28, 29. Nice. Almost there, we're over halfway. Here's A20. We moved our output to D20, and we want to turn on C29. We want to pull C29 up to 5 volts. 5, 6, 7, 28, 29. There we go. Move our output load of that relay coil to D22. We want to turn on A30. We're pulling A30 up to 5 volts. Let's move our output to pin D24. And we want to pull C30, pin C30 up to 5 volts. Nice. Okay, 4 more to go. Here's output D26, pin D26. We want to pull A31 up to 5 volts to activate that input. It's a lot of fun. Okay, almost there. We've moved our relay coil to pin D28, and we want to pull C31 up to 5 volts. Okay, 2 more. Here's pin D30. We want to pull A32 up to 5 volts. Last one, pin D32. Don't short that to the ground lead. We'll be changing that MOSFET. Okay, D32's output is activated by pulling pin C32 up to 5 volts. Applying 5 volts to pin C32 right here. There we go. Isn't that neat? Isn't that neat? Let me put my probe over here. Now, I've got this chart that I used, and I'll put this up at the end of the video also. Right here is the output pins, and here is the corresponding input pins to turn on that output. Alright all, I hope you enjoyed that video. That'll help you when you go to test your Homatic output card. I'll put all these drawings and charts and whatnot up at the end of the video, and you'll be able to take screenshots and test your board. Wasn't that a lot of fun? I really enjoy doing stuff like this. It's amazing when you can see a fault and repair it. It makes this job enjoyable when you can get to the very end and know the board's good because we tested it. Folks, have a good day, and we'll see you when the sun comes up. Hello all, we've made it to the house. We're going to look at one output channel, input here, output here, of our test setup. We apply 5 volts DC and ground to C1 and C2 on the input connector. This same 5 volts from the external power supply is applied to an input. In this case, A25 on the S12, S11 connector. That one connector. When we do so, the output of 24 volts DC through the MOSFET is applied to D2, and current flows from plus 24 volts DC through the relay coil back to ground on Z32. That 24 volts is applied to the output connector on Z2 and Z30. Plus 24 volts DC on Z2, and it's ground on Z30 or Z32. In order to clip on to that plus 24 volts DC input, I applied the plus 24 volts DC to the anode of the diode and ground to the ground side of the electrolytic capacitor. Let me move this into the circuit right here and see if we can see that. Can you all see that? Up here, Z2 through Z28 is the 24 volts DC in, and I clipped on to the 1M4007 anode right here with plus 24, and the ground on C1, this 10 microfarad 63 volt electrolytic capacitor. I clipped the ground of the plus 24 right there. It was convenient to do that instead of trying to clip onto this connector right here. I have a 24 volt DC coil. In this case, this output right here from D2 to Z32. When that input is made right here, the output is energized, this relay is energized, and this contact is pulled in. When that contact's pulled in, now 120 volts AC is connected across this 120 volt AC 100 watt light bulb. When I remove the 5 volts from this input, A25, this relay was de-energized and the contact opened up and the light bulb turned off. Amazing. Amazing. Now, a couple of things you want to be worried about here is don't get your 5 and 24 reversed. Don't put 24 over here. If you do that, you'll wipe out every TTL logic IC on that side of the optocoupler. So be careful there. Don't put 24 volts over here. Another thing, we're working with 120 volts AC single phase over here. Don't let this touch your board. If this 120 volts AC gets across either the 24 volt side or the 5 volt side, you're going to have a whole boatload of work to do to repair that board if it's possible. So leave this. Be sure that your 120 volts AC is way over there in the corner and cannot get onto this circuit right here. Alright, I think that covers everything. Have a good day, folks. Enjoy the time with your families. The time runs out so fast. We'll see you when the sun comes up.